The modern construction industry doesn't just sell us square footage, it sells us a lifetime, high-price subscription to comfort. Every summer, millions of people around the world voluntarily hand over their hard-earned money to energy corporations just to avoid suffocating from the heat in their own homes. We've been conditioned to believe that the only way to survive a 100-degree heat wave is to hang a white plastic box on the wall. A box that frantically spins your electricity meter, requires expensive annual maintenance, breaks down at the worst possible moment, and forces us to breathe dry, dead, artificially chilled air. We've become so accustomed to this technological dependency that we've stopped noticing the obvious. Right beneath our feet, right in your backyard, lies a solution that can cool your home absolutely free, around the clock, year after year, without consuming a single watt of electricity. Just 8 to 10 feet underground, the soil temperature remains stable and cool all year round, regardless of whether a freezing blizzard is raging above or the asphalt is melting from the summer heat. All you need to do to claim this free energy from the planet is to lay a standard pipe worth about $150. But if you walk into any modern hardware store or consult with conventional engineers, they will never tell you about this. Architects have no incentive to design homes that live on their own. Construction corporations don't want autonomous systems because you can't build an endless business on simplicity and reliability. The idea of using the planet itself as a giant air conditioner seems revolutionary to us only because we are deeply mired in the technological arrogance of the 21st century. In reality, our ancestors perfectly understood how the physics of the Earth worked, and they used this knowledge thousands of years before humanity discovered electricity or invented Freon. 3,000 years ago in ancient Persia, in the middle of blistering deserts where daytime temperatures easily crossed 110 degrees in the shade, people built monumental underground channels called qanats. These hand-dug rivers were constructed deep underground to transport water from the mountains to the cities. But Persian architects quickly noticed an amazing side effect. The air passing over the surface of the subterranean water in these tunnels cooled down instantly and became incredibly fresh. They connected these underground galleries to tall ventilation towers on the surface, which today we call bad gears or wind catchers. The hot desert wind would hit the tower, rush downward into the subterranean channels, leave all its heat behind, become saturated with cool moisture, and enter the living quarters of palaces and caravanserais. Inside these buildings, a comfortable coolness was maintained all year round, while the stones outside were literally baking. Similar passive geothermal cooling systems have been uncovered by archaeologists in ancient Rome and within the cave complexes of Buddhist monks in China. Ancient builders didn't fight nature with brute force and fossil fuels. They relied on elegant laws of the universe that work always and everywhere. To understand why this system is so effective, we need to strip away the complex formulas and look at the physics of the process in the simplest terms possible. The Earth possesses a remarkable quality known in science as thermal inertia, or the thermal mass of the soil. The top layer of soil, about 2 feet deep, responds sharply to the shift between day and night, heating up under the sun and cooling down in the dark. But the deeper we go, the weaker these fluctuations become. At a depth of about 8 to 10 feet, an incredible phenomenon occurs. Diurnal temperature spikes disappear entirely, and seasonal shifts lag by several months. This means that when the peak of summer heat arrives above ground, the cool air of spring is just reaching this depth. The soil down there maintains a stable 55 to 58 degrees Fahrenheit. The Earth acts as a massive thermal flywheel that smooths out extreme weather peaks. A passive geothermal cooler, or as it's more commonly known, earth tubes, is designed incredibly simply. We take a pipe of a specific length and diameter, bury it in the backyard at that exact depth of stable temperatures, run one end outside to intake fresh air, and bring the other end into the house. When hot summer air at 95 degrees enters this underground highway, it moves through the pipe and makes contact with its walls. The pipe walls are continuously cooled by the surrounding soil. A constant heat exchange takes place. As it travels through the subterranean maze, the air rapidly sheds its thermal energy. By the time it enters the house, we get a clean, fresh airflow at around 65 to 68 degrees. Independent studies from the University of Arizona and data from FEMA prove that properly designed earth tubes can slash building cooling costs by 80, and in some climate zones, up to 90%. The system relies on natural buoyancy or a tiny silent fan drawing just 30 watts, which simply helps the air overcome frictional resistance in the pipe. Compare that to a traditional AC unit drawing 2 to 3,000 watts per hour, and you'll see why this technology is a direct threat to utility monopolies. However, if you open up the internet and start reading DIY forums or watching videos by enthusiastic eco-vloggers, you will only see a beautiful, idealized picture. They'll show you how amazing it is to bury a cheap corrugated plastic pipe in your garden and enjoy free cold air. And right here is where things get interesting. There is a massive, potentially dangerous problem that all these creators either gloss over or simply don't understand due to a lack of engineering background. If you make this single mistake, your free air conditioner will turn into a ticking biological weapon that will make you and your family seriously ill. Let's speak honestly and bluntly, without any filters. The ultimate enemy of any underground ventilation system is the laws of thermodynamics, specifically the dew point. When hot, humid summer air hits a cold underground pipe where the wall temperature is only 55 degrees, the exact same thing happens as when you pull a cold soda can out of the fridge. Moisture begins to condense heavily and rapidly on the inside walls of the pipe. Water starts running in streams right inside your underground system. If the pipe is buried haphazardly without precise calculations, this moisture will pool in low spots and ridges in the plastic. Inside a subterranean tunnel, in pitch darkness, warmth, and high humidity, absolutely perfect, greenhouse-like conditions are created for the proliferation of black mold, fungi, and deadly bacteria like Legionella. Within a couple of months of operation, a poorly designed system will start blowing millions of toxic spores into your home instead of fresh coolness, and you'll be breathing them in every single minute. On top of that, depending on your region, you have to contend with radium and radon, radioactive gases that can seep through the joints of cheap pipes directly from the soil. But does this mean we should abandon the technology? Absolutely not. It simply means you need to approach engineering with a brain, not just a shovel. To transform earth tubes into an absolutely safe, everlasting, and flawlessly operating system, you must implement 3 fundamental engineering solutions that completely eliminate all risks. First, forget about cheap, flexible corrugated pipes from the local hardware store. Water is guaranteed to get trapped in their ridges forever. You must use rigid, smooth, thick-walled pipes. The ideal choice is specialized polypropylene pipes designed specifically for ground air heat exchangers. Their main advantage is that their inner layer is factory-coated with a special compound containing silver ions. Silver is a powerful natural antibiotic. The silver molecules are permanently embedded into the structure of the plastic. They don't wash away with water, and over decades they completely block the growth of any bacteria or fungi on the pipe walls. Even if moisture appears, it remains sterile. Second, the layout geometry must be flawless, straight as a line. The pipe must never run perfectly horizontal or wavy. Rent a mini excavator and prep a trench with a strict, unyielding slope of at least 2%, either in the direction of the airflow or against it. This means for every 10 feet of pipe length, it must drop by nearly 2.5 inches. This slope guarantees that under the force of gravity, every single drop of condensed moisture will immediately drain to one single, lowest point in the system. Third, at this lowest point, usually right before the pipe enters the house foundation or at a turn in the yard, you must install a sealed inspection manhole or condensation sump. This is a small vertical shaft where all the moisture collects. At the bottom of this sump, a simple utility pump with a float switch is installed. As soon as the water level hits a critical point, the pump automatically wakes up, evacuates the water out into the storm drain or onto your lawn in 2 seconds, and goes back to sleep. This ensures your underground air highway remains dry, clean, and sterile. Additionally, a filtration box rated at least G4 must be installed at the outdoor intake to catch dust, pollen, and small bugs, while the intake hood itself must be sealed with a fine mesh to keep out rodents. Now let's look at the cold, hard math and calculate the real economics of this system, because numbers don't lie. How much does it actually cost to build a passive air conditioner like this with your own hands? You'll need about 130 feet of rigid pipe with a diameter of 6 to 8 inches. The cost of these pipes will run around $100 to $150. Renting a mini excavator for one working day to dig a 10-foot deep trench will cost another $100 or so. Add in the plastic inspection sump, a cheap pump, and a couple of filters, and that's another $50. In total, your raw expenses for materials and machinery will come out to around $300 if you handle the basic labor yourself. Now look at the expenses of an average homeowner relying on conventional split systems. Buying and installing a decent AC unit today costs at least $500 to $700 minimum, but that's just the starting line. In peak summer months, an AC runs an average of 10 hours a day, drawing about 2 kilowatt hours. Calculate the electricity rates in your area, multiply that by the 90 days of summer, tack on the cost of regular refrigerant recharges, filter cleanings, and the inevitable compressor replacement in 5 to 7 years. On average, a classic air conditioner completely pays back its initial cost to the builder, but immediately starts draining hundreds of dollars out of the owner's pocket via hidden operational costs year after year. Earth tubes pay for themselves entirely within the first 2 seasons of operation. After that, the system starts generating pure profit in the form of money saved on utility bills. But the greatest advantage cannot be measured in dollars. It's the quality of life. Anyone who has spent long periods in a room with a running AC knows that unpleasant sensation. Dry eyes, a stuffy nose, and a mild headache from a lack of fresh oxygen. An AC doesn't pull air from the outside. It endlessly recirculates the exact same air inside the room, chilling it and stripping it of moisture. Earth tubes work on a fundamentally different principle. It is a fresh air ventilation system. It continuously supplies your home with massive volumes of fresh, oxygen-rich outdoor air that has been naturally filtered and cooled by the earth. In a house like this, you sleep completely differently. Chronic fatigue disappears, and kids stop catching colds from icy blasts of artificial air. Ask yourself, if this technology is so simple, economical, and healthy, why don't we see it in every single custom home being built? Why don't architectural firms build earth tubes into standard master plan communities? The answer lies in the structure of the modern housing business. Modern housing is engineered around a single principle: maximizing profit margins per square foot at the exact moment of sale. It is highly profitable for a developer to throw up a box as quickly and cheaply as possible, wrap it in cheap plastic vapor barriers, turn the house into an airtight thermos, and then fix the resulting suffocation and heat problems in the crudest way possible, by forcing the buyer to install an air conditioner at their own expense. The industry has no appetite for solutions that require long-term planning during the excavation phase. You have to bury these pipes strictly before the foundation is poured and the yard is landscaped. This requires a culture of construction, an understanding of the site's geology, and precise engineering calculations. It is far easier to check a box on the paperwork, hand over the keys, and dump the entire financial burden of operating the building onto the consumer's shoulders. Earth tubes are more than just an alternative cooling method. They are a manifesto against the concept of planned obsolescence that defines all modern home appliances. An air conditioner has an expiration date. Its control boards fry from power surges, its compressor wears down from friction, and its coils are eaten away by corrosion. It is a system programmed for eventual failure. An earth tube, neatly laid in a deep trench and protected by tons of soil, contains absolutely zero moving parts underground. There is simply nothing down there to break. Plastic, shielded from ultraviolet rays and kept at a stable temperature, takes over 200 years to decompose. This system becomes a permanent, everlasting organ of the property itself. It will still be operating when your grandchildren are managing this home. It makes you truly independent of power grids, energy crises, rolling blackouts, and soaring utility rates. Even if a massive grid failure hits in the dead of an absolute heat wave and your neighbor's houses begin to bake, your system will keep silently, autonomously delivering crisp, cool air into your rooms, drawing nothing more than a tiny car battery to power a small inline fan. The world around us is engineered far more intelligently than the plastic gadgets we've surrounded ourselves with. If you allow basic physics to just do its job, it can solve our most complex domestic problems at zero cost. The housing industry made us forget that a home should be a living organism that breathes and interacts with its planet. But restoring that connection is never too late. If you are currently planning a home build or have open space in your backyard, stop subsidizing someone else's business. Let the physics of the earth take care of your comfort. In this video, we broke down exactly how to force the thermal inertia of the soil to gift us free cooling in the summer heat. But what happens when the seasons shift and we face the exact opposite, far more brutal challenge? How to heat a large home in the dead of winter without going bankrupt on gas, wood, or electricity. There is an ancient technology that completely flips conventional heating on its head, allowing you to warm your living spaces with nothing more than a single handful of dry twigs. If you want to find out how the simple laws of thermodynamics and the right layout of clay mass can eliminate your heating bills forever, the video on that is already waiting for you on your screen. Click right there, and we will keep uncovering the secrets of radical autonomy.